Welcome to the part 3 of the course Introduction to Computer Networks and Data Communication. So, for this part, we'll be talking about MAC addresses, IP addresses, and various types uh, of IP addresses. Then, we'll be talking about Internet of Things, Web of Things, and what are the components of Internet of Things and Web of Things. My name is Makinde AI. So, what is MAC address and what does it connote? MAC address stands for Media Access Control. The full meaning of MAC itself is Media Access Control. So, a MAC address is a unique identifier given to devices which communicate over a local area network. In our former class, we talked about the various networks and we've discussed about local area networks. So, a MAC address is a unique identifier given to devices which communicate over a local area network. And that's why you hardly see a device with the same MAC address. Your phone, when you have issues with your phone, one of the first thing they will request for is your MAC address. Check the carton of your new devices. There's always a MAC address on it. So, a network interface card is given a MAC address at the point of manufacture, and that is why you see virtually almost all your devices that communicate with a network has what we call the network interface card. So, and for that network interface card, they are given a specific MAC address when manufacturing them. So, and that is why MAC addresses are static, meaning they can never change. So, but at the same time, MAC addresses make it possible for switches to efficiently forward data to the intended recipient, because when you are moving data from one uh, computer devices to another, because of the unique identification of each of these devices, some of majority of them can be easily targeted. You can easily forward a specific data to a specific device, and that's why it's easier for a switch to forward data to the recipient. And in most cases, any device that contains a network interface card has a MAC address assigned during manufacturing. And that is why a device connecting to a local area network already has a MAC address. And if it moves to a different network, then the MAC address will stay the same because MAC address doesn't change. And for MAC address, the way it looks like is each MAC address is a 12-digit hexadecimal numbers, that is 48 bits in length, of which the first six digits contain the manufacturer ID called the organization unique identifier, while the last six ID represents the serial number assigned to the card by the manufacturer. So go and check if you have some friends using maybe Techno, uh, Oppo, and the like. Check the first six digits of their MAC address and see the difference. So the first six digits is the unique name. It's just like that. Your unique identifier is your matric number. The first, mostly the first maybe maybe 4 or 6 or 8 digits. I don't know the way your matric number looks like, but at least your matric number will identify you to your department, which is constant, is a unique identifier. Then why the last digit changes? Because the last digit depends on when you got admission, the year you got admission, and the like. So, and that's the way MAC address works. So, what's IP address? An IP address is a unique identifier given to devices which communicate over the internet. MAC address is a unique identifier given to the device itself when communicating over local area network. But an IP address is a unique identifier given to devices which communicate over the internet. That is the one. IP address can be static, meaning they can stay the same, or dynamic, meaning they can change. And that's why you see some people having multiple IP address. You move from one system to another, you move from one location to another with your IP addressing changing continuously. So IP address make it possible to deliver data to the right device, and a device connecting to a network will be given an IP address. If it moves to different network, then the IP address change. That's why when you move, you connect to MTN, check your IP address. It will be different from when you connect to Glo. So IP address changes depending on the network. So, and IP address can change if node is moved from one network and connect to another network, like I said. While IP address can be divided into two types, we have the IP4, IPv4, and the IPv6. The IPv4 version is a 32-bit numeric address written as four numbers separated by periods, where each number is the decimal base 10 representation for an 8-bit binary base 2 number. And each can take any value from 0 to 255. And the example of an IP address of IPv4 is 192 full column 168 full column 0 full column 178. So IP address v4, which simply means Internet Protocol version 4, is represented as a 4 blocks of denary numbers between 0 and 255, separated by full stops. So each block is 1 byte. Each block is 1 byte. Like I said, they are separated by full columns, some separated by dot, but the most common one is separated by dot. So if you have 192.168.0.1, so that 192 there, the first 192 is a block. The second 168 is a block. The 0 is a block. The 178 is a block. So that 192 is a 1 byte or 8-bit block. 192 is a 1 byte or 8-bit block. Or let's say the 12 is a 1 byte 8 bits block. 123 is a 1 byte 8 bits block. 225 is a 1 byte 8 bits block. 32 is a 1 byte 8 bits block. So each address is 4 bytes. That is, a single IP address of IPv4 is a 32-bit block or a 4 bytes block. If you add each of those blocks together, each block is 8 bits. So we're having 4 blocks. So 8 plus 8 plus 8 plus 8 gives you 32. So IPv4 provides over 4 billion unique identifier addresses. That is 2 raised to the power 32. But if you look at the population of people around the world, we have over 7 billion people. And each person in the world has several devices. Like you yourself, most of you have laptops, you have phones, some even have 2, 3 phones. So now imagine 7 billion people with 4 phones. That will be 7 times 4. That will be, we'll be expecting like 28 billion unique addresses in order to be able to efficiently assign IP addresses. So we know for IPv4, the maximum it can provide is for over 4 billion unique addresses. So if you have 7 billion people with about 4 devices each, which is about 32 billion, what happens if we run out of IP address? In that case, there was now an introduction of IPv6, which is the Internet Protocol version 6. IPv6 is represented as 8 blocks of 4 hexadecimal digits separated by columns, and each block is 2 bytes, 16 bits for each of the blocks, and each address is 16 bytes, which is 128 bits. For IPv4, the total is 32 bits, while for IPv6, the total is 128 bits, so which is equivalent to 16 bytes. So the major difference between IPv4 and IPv6 is the number of bytes and the number of bits. And for IPv6 could provide over 1 billion unique addresses for every person on the earth. IPv4 provide over 4 billion unique address. 4 billion unique address altogether. And we have 7 billion people and countless devices per person. That's for IPv4. But for IPv6 could provide over 1 billion unique addresses for every person for every person. So if one person can get up to 1 billion unique addresses, so IPv6 has automatically solved our problem. No matter the number of population, we won't be able to exhaust the addresses provided by IPv6. So, and that's all about IPv6 and IPv4. So let's now move to Internet, Web, and Internet of Things. Internet is the global network of computing devices, including desktop, laptop, servers, tablets, mobile phones, and other handheld devices. Aside that, printers, scanner, routers, switches, gateways falls within this scope. Whereas smart devices like TV, refrigerators, AC fans can also communicate with the network. And aside that, your doors, security cameras, and the like, they can also communicate through networks. Since the internet is evolving every day, it is difficult to visualize or describe each and every aspect of the architecture of the internet. And if you see it, it is with the use of modem, be it wired or wireless, when connected over the local internet service provider, which connects to a national network. That ISP can connect together, forming a regional and regional networks. And such country-wide network form the internet backbone of a nation. So how does IoT comes and what does it entails? The Internet of Things refers to the vast and growing network of physical devices that are connected to the internet. Devices connected to the internet simply referred to as Internet of Things. Your phones, your fridges, your refrigerators, your ACs connected to the internet, capable of collecting, transmitting, and acting on data without human intervention, then we refer to that as Internet of Things. So let me define it again. Internet of Things refer to the vast and growing network of physical devices that are connected to the internet, capable of collecting, transmitting, and acting on data without human intervention. These devices are often called smart devices, and they are embedded with sensors, softwares, and connectivity modules that enable them to communicate with other devices and systems over the internet. That is why you can sit at home and use your phone to put up put on your AC. You can switch off your fridge using phone. That's Internet of Things. You can use your phone to put on the fan. That's Internet of Things, because ability to communicate and send data over the internet. Aside that, IoT span across sectors and applications, including our smart homes. Your The agricultural industry, for example, make use of soil sensors and irrigation system, smart irrigation system. That's why you see there's something we call smart irrigation. You are going to let's say, are you in part? Yes, yeah. Most of you are a final year student. Now imagine your project topic falling within the range of smart applications. So, and when you say smart, that means you need sensors. There are devices you can put in the soil that will transmit the humidity of that soil, that will transmit the temperature of the environment, that will transmit the water level of the soil, if dry or low. If the water is dry, it will send a signal to the devices that activate an actuator that activates the uh, the irrigation system and try to water the soil. All these are the influences of IoT. So, what makes IoT transformative is its ability to turn everyday physical objects into intelligent agents that can sense their environment, make decisions, and act in real time. Please take note of that. What makes IoT transformative is its ability to turn everyday physical objects into intelligent agents that can sense their environment, make decisions, and act in real time. A typical IoT system involves four main layers. A typical IoT involves four main layers. The perspection layer is the first one, which is the level of the devices and the sensors that dictate data. That's the first layer of an IoT system. The second layer is the network layer. This network layer transfers data to servers and clouds. The third layer is the processing layer, which is where the data is analyzed. And the last layer is the application layer, which delivers insight or services to the user. So we have four layers in a typical IoT system. The perspection layer, which involves devices, sensors that detect the data. Then the network layer, This transfers data to servers and clouds. Then the third one is the processing layer, where the data is analyzed, while the fourth one is the application layer. This delivers insight or services to the user. And a typical IoT system rely on communication technologies such as Wi-Fi, Bluetooth, Zigbee, LoRaWAN, and 5G networks. But we are talking of 5G. Uh, the Chinese people already came up with 10G. So what happens to 5G? So the world is actually fast evolving. And if we are talking about IoT and we are talking about 5G. Now imagine a situation where we now have 10G. We are not even talking of 6G. We are not talking of 10G now. So if IoT relies solely on 5G, what now happens to 10G? So IoT enhances efficiency, convenience, and automation, but also represent challenges in terms of security, interoperability, and data privacy, as billions of devices generate large volumes of sensitive data. And that's why in these days we talk about large data, big data, because virtually every one of us generates large amount of data. Organizations generate large amount of data, and that is why we have an economy that is being driven by data worldwide. So without the data, we might not be able to achieve many things. And with the advent of data, we have what we call the machine learning, the prediction, the AI generation, because AI solely relies fully on data and large amount of data. So if our communication, if devices, if the environment is being driven by large amount of data, then what are we talking about? 5G and IoT are the deal, but at the same time, we are no longer talking about 5G. We are no longer talking about 6G. Some people have already worked and deployed 10G. So, but in Nigeria, we are still struggling with 3G, 4G. So what is that's all about IoT. So what's now Web of Things, the WOT? So by simple definition, WOT integrates IoT devices into the web using standard web technologies, HTTP, REST, and JSON. The key difference between the two is IoT is device connectivity, while the WOT is the web-based interoperability. IoT is device and web is web interoperability. So the Web of Things is built upon the foundation of IoT by using standards and protocols to make devices more interoperable, accessible, and programmable across different platforms and vendors. Like I said, while IoT focuses on connecting things to the internet, WOT focuses on integrating those connected things to the World Wide Web. That is, you have your sensor. You have a sensor that can sense the humidity of the soil. So what it means is that you need a web application to actually pass that data from the soil sensor to your phone. So with your phone, you'll be able to see real-time value, real-time data of sensors from your soil. And that's the essence of the Web of Things, because it enables easier communication, control, and data exchange using similar web technologies such as HTTP, RESTful APIs, WebSockets, and JSON. In practice, WOT introduces the concept of a thin description, not well. It introduces the concept of TD, that is the thin description, is a machine readable metadata file that describes a device capabilities such as its properties, actions, and events. So Developer can then interact with any device that conforms to the WOT standard using a common API, application programming interface, regardless of the device internal protocols. That is. So for instance, let's look at a smart light bulb from one manufacturer and a smart plug from another manufacturer. Both can be controlled from the same dashboard on your web interface using a standardized web interfaces. So this eliminates the vendor lock-in, the bottleneck, and simplify the development and promotes reusability and scalability of IoT solutions. So what's now the relationship between the two? What's the relationship between IoT? Okay, for the WOT, aside that we have it has several layers too. It has the access layer for the device. It has the find layer for the service discovery. It has the share layer for data exchange via the web standard. Then it has the compose layer, which is the integration of the web apps. So what are the differences between IoT and WOT? In terms of communication, proprietary protocols. For WOT, we have the web standards, the HTTP and the rest. In terms of interoperability, IoT is limited. For WOT, it is high. It is not limited. It's web-based, so it can work across board. In terms of scalability, IoT is moderate, but WOT is very high. So, but both aim to create a smarter environment and systems by integrating the physical and the digital worlds. Their core focus differs anyway. But IoT is primarily concerned with connectivity and functionality of devices, how they sense, collect, and transmit data. But WOT, on the other hand, is concerned with interoperability and accessibility, making data and capabilities of these devices available and manageable through web technologies. So in terms of, in a simple term, IoT connects the things, while WOT make those things. IoT connects the things, that's why it is called Internet of Things, while WOT make those things. But together they form a powerful ecosystem that can enable advanced applications such as smart cities, industrial automation, and personalized healthcare systems. So applications, like I said, include smart cities, healthcare, agriculture, and industry 4.0, that is the maintenance. So our next discussion will be on the World Wide Web, the WWW. So WWW, I'm not talking about the WW in the wrestling or WWE. No, not that. I'm talking about the World Wide Web. So the WWW is an ocean of information stored in form of trillions of interlinked web page and resources. The resources on web can be shared across or can be shared or accessed through the internet. The resources on the web can be shared or accessed through the internet. So if WWW is an ocean of information, those information can be accessed through the internet. And that is why Sir Tim Berners-Lee, a British computer scientist, invented the WWW in 1990 by defining the three fundamental technologies that leads to the creation of web. The first one is the HTML. The second one is the URL. The third one is the HTTP. HTML, we all know what HTML means, hypertext markup language. This is a language which is used to design a standardized web pages so that the web content can be read, understood from any computer. Basic structure of every web page is designed using HTML. But at the same time, there's something we call the extendable markup language, XML. So, but that's not the topic for this class. So I won't be going into the XML, but we are to be talking about HTML, URL, and so. But what's now URL? If HTML is being used to design the web pages, what's the URL? URI simply means uniform resource identifier. Uniform resource identifier. It is a unique address or path for each resources located on the web. For every web page, it has a unique identifier. And behind those unique identifier is what we call the IP addresses, but we'll get there. So it is also known as the URL, URI or URL. If I ask any one of you, what's the URL of your school? Simply tell me www dot this, and URL changes. It depends on your school name or your school unique taste. So, and then for every web page on the web has a unique URL. Every web page, the about us on your web page will be different from the the service page. It will be different from the portal URL. So every web page on your website has a unique URL. URL is not only the domain name, but it contains other information that completes a web address. If you look at the sample URL we have on the screen, we have the http www.ncrt.nic/textbook/textbook.html. The www.ncrt.nic.inc is the domain name. Everything all together is the URL. But that www.ncrt.nic.in is the domain name. You yourself, you can have your personal domain name. If my name is Makinde, for example, I can have a specific domain name. I call it www.makinde.org. www.makinde.org will be my own domain name, which is unique, a kind of unique identification of my domain name. So aside that, we have what we call the HTTP, the hypertext transfer protocol. Is a set of rules which is used to retrieve link pages across the web. The more secure, the more advanced. That is why we have HTTPS, which is for the secured version of the HTTP. So lastly, we'll go to the domain name system. What's a domain name? Like I said, your name can be a domain name. Without a domain name, you can't have a functioning website. So, and we know the internet is a vast ocean of information which store billions of info. But each website is stored on a server and which is connected to the internet, which means each server has an IP address. So, a DNS stands for domain name system. We are now talking about DNS, which is a domain name system. So a DNS stands for a domain name system, and it acts like the phone book of the internet. That is translating human-friendly domain name like Google. When you type Google in your URL or URI, it translates that google.com into a machine-readable IP address. For example, if I type www.google.com, the domain name system translates it into a machine readable IP address like 172.1.217.0.46. So behind every domain name, there is a mask, a sheet that represents a kind of unique IP that represents that domain name. So a domain name is actually the name itself, but behind it is an IP address that represents that domain name, and that's the essence of a domain name system. It helps you in translating human-friendly domain name to a machine-readable IP address. And why do we need even a DNS? Computers communicate using IP address, like we explained earlier. but humans find domain name easier to remember. If we start asking every student to be memorizing domain IP address instead of domain name, okay, my university IP address is 192.168.177.120. Then my Google IP address is 22.10.5. How many will a student memorize? It will be difficult to memorize. So that's why we have the domain name. So the domain name make it easier, but the domain name server helps help the system translate that name into the IP address, and that is why every website, every domain name has a unique IP address. So DNS eliminate the need to memorize numbers. So how does DNS work? How does it work? How does DNS work? The DNS server, how does it work? Number one is when you type www.google.com in your browser, your device check the local cache. That is, it first your computer check if it already knows the IP address. Maybe there's a previous visit, and that's why you see you hear of cache. Is the essence of cacheing application, cacheing data on your web browser is to make it easy for your system to access those data in future visits. So your system will first check for the cache data if it exists. Then secondly, query goes to the recursive DNS resolver. If the IP address is not cached on your device will now ask the DNS resolver, which is usually provided by your ISP or the public DNS like Google. The resolver will now ask your root DNS server, which then now directs it to the correct top level domain server. That is, the first step is check the local cache. The second step is that your device will now ask the recursive DNS server. Then thirdly, the root DNS server is now contacted. The resolver will be the one to connect the DNS server. So the DNS server will now check, okay, is it .com, is it .org, is it .edu.ng? That will now determine the resolving of your IP address of the domain name. So, and that's the essence of the root DNS server. It directs it to the correct top level domain server. If it is it .org, .org.ng and the likes. So the .org now server knows that authoritative DNS server holds the IP for your domain name. So since the top level domain server knows that your DNS server holds the IP address, it will now provide the correct IP address for the domain name. Then it will now load your website. So your browser connects to the IP address and load the website. So we have about 6 steps in how DNS works. Number one is check the cache on your device. If it exists, then it's easier. But if it doesn't, it connects to the recursive DNS resolver, and the DNS resolver contacts the root DNS server, and then the root DNS server will now point to the authoritative DNS server. Then the authoritative DNS server will now respond by providing the correct IP address for the domain name. Then it will now load the website. That's the short way it works. And what are the types of the DNS server? Like I said, I've already mentioned, we have the recursive resolver, we have the root DNS server, we have the TLD server, and we have the authoritative DNS server. So the recursive resolver received requests from devices and fetched the IP address. The root DNS server direct queries to the TLD, the 13 root server worldwide. Then the TLD server manage domain extension .com.org.net and the likes. And the authoritative DNS server holds the actual domain DNS records for the domains. So what are the common type of DNS server we have? We have the A record, we have the AAA records, we have the CNAME, we have the MX record, and we have the TXT record. So I won't be delving that into that fully. So example of a looking DNS server is you type your domain name, it asks for the recursive, it cache it. If not, it goes to the TLD server. The TLD server points to the authoritative server. The authoritative server returns the IP address, and your browser connects